Okay, 120, 6.4, adding, subtracting, and or multiplication, which is what it's labeled. This is actually talking about rational numbers, not just adding and subtracting anything. Rational, not rational, radical. We're doing square roots, right? Okay, not rational, we're doing radical numbers. Okay, just remember, when you were doing like variables, if you had like 7x plus 9 minus 2x minus 16, remember we added the like terms? Okay? If something has the exact same square root, it's a like term. Okay? So we're using what we've learned before. You don't have to write this on your notes. You know that what adding like terms is, right? So what we're going to do is we're going to jump into this. These are like terms, aren't they? Okay? So if you have 7 squared root of 5 plus 4 squared root of 5, what do you have? 7, 8, 9, 10, 11 square root of 5s, right? Okay? Like terms. We have 2 and we have 9. So we have a total of 11 square root of 3s. And you don't have to put every single example down, because I usually put 2 or 3 of every type thing to make sure that you see it a few times. So if you can't keep up with the writing, just make sure you have at least one of these would probably be enough, because they're all the same type thing. 8 minus 5, there's 3 of those, right? Simple enough? These are all the same, right? They're all square root of 6s. So how many of them do we have? We know it's going to be of square root of 6s. You have 5 minus 9 gives you negative 4. Negative 4 minus 4, negative 8 of those. Okay? Now these are square root of 10. See, I gave you more than one of the same type thing. 3 minus 8, that's a 3. I don't know if you can tell. You have to write every single example down. 3 minus 8 is negative 5. Negative 5 plus 7 is what? 2. Okay. So those 2, you could write either one of those, and that would be an example of that. You don't need to write both. Okay. Now we have one more like what we wrote before, where we had x's and we had numbers. We have these are like terms, and these are like terms, right? See, this has cube root of 3s. This has square root of 5s. See that? How they're different? They're not like terms. These are like terms because they're both cube root of 3s. Is that big enough? Okay. Okay. So these are like terms because they're both cube root of 3s. So we're going to add the coefficients of these. So how many cube root of 3s do we have? 4 plus 2, 6. See that? Okay. And then we have a negative, that would be a negative 1, right? And a positive 1, square root of 5s. That goes away, right? Negative 1 and positive 1. So that's really combining like terms, you just ended up with that term. Okay? Okay, next. Those are not like terms, are they? This goes back to the section 6.3, the section we did right before this, where we were simplifying the radical part. Okay, so we need to simplify these radicals. Okay, let me you put down that you got here. I got your text. Okay, so 45, do we have a perfect square that divides into 45? 9. You might want to get your square root sheet out, your cubes and squares sheet, because you can look at it and find a number easily that goes into it. 9 times 5 is 45, right? So this part turns into 8 times 3, because square root of 9 is 3. Okay, how about this part? Oops. What goes into 20? There we go, 4 and 5. Okay, so square root of 4 is 2, right. Now we have like terms. They're both square root of 5s. So we have 24 plus 14 is 38 square root of 5s. Oops. I did that up there where you couldn't see it. So we had 24 plus 14 was our coefficients. Adding those up, we have 38 square root of 5s. So you got to kind of put what you already know into action to do these. Okay, let's do this one. Square root of 12 is what times what? 4 and 3. We want to put the 4 in front, not the 3, because we want this to come out to something. Square root of 4 is 2. Keeps everything lined up if you put the perfect square first. Okay, the 16. What times what? The 27? 9 times 3. We could have guessed it would probably have a 3 because this one had a 3 at the end. Okay, 16, square root of 9 is 3. Okay, so we know our answer will be in square root of 3, right? So our coefficients are 9 times 2 is 18, plus 16 times 3 is 48, which gives us 66 square root of 3. So this problem is like this problem. As long as you got one of them written down, you're in good shape. You have an example of that. In fact, we have 3 of these examples because the next one's the same thing. So if you walked in after this one, having this one and this one would be enough. Okay, 18. I'll change colors on this side. 1872 is what times what? 9 times 8. But 8 also divides and has a 4 in it. So the 8 is 4 times 2, so you'd end up with a 2 left over at the end. So what is it times 2? 36. That's a perfect square also, right? Let's go ahead and jump into that one instead of having to do 2 steps then. Now we're going to guess, oh, look, this is going to have a square root of 2 left. I bet you that's going to divide by 2 and have a perfect square. Most likely, right? Let's go ahead and put it there and see if that works. Let's finish this. 18, what's square root of 36? 6, right. Okay, now we have the plus 2. What times what is 96? 2 times what?
48.
48's not perfect, is it? Shoot. Okay, then that one didn't work. This one's a little different. It may have 2 answers. Okay, 48 didn't. Let's do 4. Let's see, 96. We know 4 is a perfect square. So let's divide by 4. And what do you get? 24? Okay. That'll divide by 4. is what, 6? So you could put 16 into it. 16 and then go 6 times. It's not going to work for the 2 here. It doesn't always work, okay? All we're going to be able to do here is just simplify. Okay, so 16 and times square root of 6. Two times 4 square root of 6. So we're going to have 2 terms in our answer. 18 times 6 is 108. 108 square root of 2. 2 times 4 is 8 square root of 6. And it's not like terms, so that's as far as you can go. If you just walked in with some important stuff, very important. Okay. Cube roots. Now we need to remember our perfect cubes. What were some of the first cubes? We had 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. 4, 4, 4 is 64, right? 5, 5, 5 is 125. Okay, that's far enough. These are some perfect cubes. You need to see if you can divide these into something that has a 3. Okay? So you want to make a list of the first few, if it's a 3 or a 4 or something here, so you know what you want to try to divide into it. Okay, so we leave the 3 out here. 16 divides by 8, right? So we want to put the perfect one first. 16 is 8 times 2. Okay? And then we don't have a coefficient, so we don't have to put a number up here. 54, we hope we can find a good one. What will go into 54? 2? Yeah, 27 is our perfect cube, so we'll put it in the front. 27 times 2. And we're seeing here that we have like terms, aren't we? Because that's what's going to end up left. Well, we should eventually get to where we see that. If we don't see it yet, we will eventually see that. Okay, so this is a cube root of 2. 3 times what? 2. The cube root of 8, yeah, remember this? The cube root of this was our 2. Okay. So the cube root of 8 is 2. And then we'll put our plus. Cube root of 27 is 3. Oops. So we see here, these are both cube root of 2 terms. Right? Get rid of that. Get a blank sheet. That's not a blank sheet. Oh my God. Sorry guys. I want to just get this out of the way. Okay, so we have, they're both cube root of 2's. This one is 6 plus 3. Right? So we have 9 cube root of 2's. Okay. Now let's simplify this if we can. Square root of 50. Get your squares out. 1, 4, 9, 16, 25. What will go into 50? This perfect square. 25 times 2, right? 18, what are we on to 18? Perfect square. 9, right. And perfect square into 32, don't use 4, there's a bigger one. 16. And you could have almost guessed it would be a 2, right? Okay. So we have 5 times 5, square root of 2. 2 times 9, not 9, 3, square root of 2. 9 times what? 4, square root of 2. Okay, we have 25 minus 6 plus what? 36. So we're going to have a square root of 2 term because I don't think they're all going to cancel out. 25 minus 6 is 19. 19 plus 36 is 55. There you go. Okay. Let's wrote that down. We've done an add and subtract. Now we're jumping into multiply. Might as well make it bigger, easier to see. Okay. One number on the outside, just like you did when you had variables. You're multiplying, you're distributing it through to get rid of parentheses. Okay, so this times this, put the number in front just like you would have if it was x times 4. Write the radical at the end like you would a variable. 4 squared of 5 minus this times this. Okay, first we need to establish something. Let's set this aside for a second. You don't have to write this down, I'm just going to show you something. What do you have when you have square root of 6 times square root of 6? It's square root of 36, right? What does it end up being? 6. What? Square root of 4 times square root of 4? 16, which is 4. Look what's happening. Square root times itself is just that number. So what's square root of 5 times square root of 5? It's 5, right. So square root of 12 times square root of 12, square root of 144, it's 12, right? So instead of having to write that in between step, you see a square times itself is that squared, which gets rid of the square root. Okay, there. That being established, now we have 2 times square root of 5 times square root of 5, right? 2 square root of 5 times the square root of 5 on the outside. This turns into 5, right? We just showed that. So we have 4 square root of 5, that's 4 stuff. 4 square root of 5 minus, this part is 5. 2 times 5 is 10. Down where you see all of it at once. Okay? How's that? Give that 2 seconds to soak in. Hopefully you're not very thick.
Soaking.
Soaking. Is it good for you? It feels good. Yeah. Woo-hoo! Okay. Inside joke. Okay. You had to be here at the beginning of class. Okay, this times this is 2 square root of 6, right? Plus, what is square root of 6 times square root of 6? 6. Can I go any farther? There's no like terms. There's no more simplifying. It's as far as you can go on that one. That feels good, huh? Yeah, we feel good. Yeah. Alrighty. We're having too much fun. You can't have fun in math. What's wrong with you? Okay. This times this. We put the 2 in the front. Square root of 3 times square root of 5 is square root of 15. Do you remember that at all? Is that something we need to establish? This times this is square root of, remember when we were doing them and simplifying them, you could multiply them together? Yeah? Okay, we know that. Now we're going to do this times this. The 3 stays in the front. Square root of 3 times square root of 4? Square root of 12, right? But this should have been turned into 2 probably, huh? Let's leave it as square root of 4 times square root of 3. Because that way we don't have to make a step of breaking it back apart to simplify it. This is as far as we can get. 3 and 5, that neither one of those are perfect squares. We're going to leave that. This is 3 times 2, square root of 3. This is a 4 in case you can't see it. Made a big mess over here. Okay, it's still a mess. Made a bigger mess. Okay, so now, can we do anything? Well, we can't combine them, they're not like terms, but we can simplify that. 2 square root of 15 minus 6 square root of 3. And that's as far as we can go on that one. Cube roots. We need our list of cubes again. Not our ice cubes. Our list of cubes, okay. There's our list of cubes that we made. Okay. Right. Let's just make a big mess here. Okay. Okay now. Cube root of 2 times cube root of 4. They're both cube roots, so we could say cube root of 2 times 4 is 8. That's good. Now, we're going to do it times the second one. Leave the 2 in the front. Let's multiply those cube roots. 32 times 2. 64. Look what we have. We have some perfect cubes there. This one's a perfect and that one's a perfect cube. Cube root of 8, 2. Cube root of 64, 4. So, we have 2 minus 8 is negative 6. That looked like it was going to be something a little crazy, huh? It turned into just a number. They won't all do that, but that one did. That's cool. Okay. That one won't turn into a number because it's got letters in there. Okay, so multiply this. 2 times 5 is 10. The cube roots. Y squared times y. What's y squared times y? Y cubed. Plus 2 times 4 is 8. And do the cube roots times each other. Y squared times y squared. y to the fourth. Let's go ahead and divide that up. Instead of a 4 here, let's put a 3 and a 1. Because we're going to be able to take the 3 one out. Okay. Can't tell that's a 3 because I made a mess again. You heard me say it, but there's a 3. Big mess now. Okay, so we have this. What's the cube root of y cubed? What? Because we love you, that's why. There you go. That part turned into that. Now, the 8's going to stay up here. This part comes out as a y, right? This part stays under the cube root. We don't have like terms, so we can't combine anything. So it got a little bit simpler looking. Not a lot, but a little bit. Okay, next problem. Y'all have the answer written down? Okay, next problem. Change colors. Okay, so we have cube root times a cube root. We leave the cube root. So this times this. 2 times 2a squared times a is 2a cubed, right? Is that right? Yes? Plus, this times this, they're cube roots. Multiply what's under them. This times this. 16. 2 and 1 is 3. Okay? Following okay? The 2 will not come out of a cube root. Can't cube anything to get 2. So that has to stay under. The a cubed can come out as a, right? This 2 has to stay under the cube root. Looks like a z. It's a 2. Okay. Can we take something out of this? The a cubed can come out as a what? A. The 16. Oh boy. 16 will divide by a perfect cube, right? So let's go ahead and break that 16 down, and we'll just take one more step to finish this, okay? 16 is 8 times 2, right? Okay. The cube root of 8 is this 2. This part's 2, so we're going to put it in front of the a. We just put it over here. And this is a cube root of 2. Do we have like terms? They're both cube root of 2's, aren't they? So how many cube root of 2's do we have? You add the coefficients, we have a plus 2a. 1a plus 2a, right? 1a plus 2a is 3a. Okay? That was fun. Maybe it's only fun for me. Okay. That's me having fun by myself again. Thinking everybody else is going to enjoy this. Yeah. Okay. Alrighty. Now let's multiply. And we have this times this. They're both cube roots, so put that cube root thing there. Multiply what's under. So the 3 and then x to what? 2 and 1. 2 and 1 is 3. So you have a 3, and x squared and x is x cubed. So that's the first one. Now minus, there's no number, you don't have to put a 1. Cube root times a cube root will be a cube root, and you're going to multiply what's under. So the 81 stays there. The x's, 2 and 1 is 3. Okay. So, the 3, we know that's going to have to stay. There's no way that's going to come out. So the cube root of 3 stays under. The x cubed comes out as what? X. Right. Okay. 81, we could actually, what cube root will go into 81? 27, right. Times 3. And I can't write that little with this. These are cube roots. So, the square root of 27, that's not 81 anymore, it's 27 and 3. So the cube root of 27, 3. We need to put this minus. This is 3. This part's going to stay under there. The x will come out, so let's leave the cube root of 3. So we brought that one out, brought this one over. The x cubed comes out as x. Are these like terms? Yes. Okay, so we have cube root of 3's. The coefficients are x and a negative 3x. 1 minus 3. Negative 2. Oh, yes, don't forget the x. Thank you. Are we having fun yet?
Yeah.
You hear me now? All right. Now we're doing a multiply where we end up 40, because it's not just one number in the front like we just did. It's 2 by 2. 2 here, 2 here, so that's like a FOIL. Okay. First times first, 2 times 2. Outside, plus 2 square root of 3. Inside, minus 2 square root of 3. Last times last. Positive, negative is negative. Square root of 3 times square root of 3 is what? 3. Square root of 9, but we're going to go ahead and go to 3. Okay, inside terms did what? Canceled. So we have 4 minus 3 is 1. Now, if you were really into factoring, remembering all of your factoring, you would have remembered that plus and a minus of something, when these are the same, is going to be the difference of squares. Remember, this is the factorization of 4 minus 3. No. Yes, 3. The square root of this would have been here. And then minus, and this times this is 3. Okay. You've just known that if you square this and you square that, you don't have to have a middle term because it ends up canceling out. So this one, we know it's going to cancel out because we have same, plus and minus, right? So we're not going to do outside, inside. We're going to do a full, FL, full. We're going to fool it. I don't think there is such a thing. Okay. First times first is 121. Outside, inside cancel. Last times last. 2. What is that? 119. So you don't even have to oi. No ois. Full, no oi. Okay, we're going to full, no oi this. First times first. A square root of A is A. Minus, last times last. B. Those won't combine, so there you go. I had to write on that, didn't I? Okay, there we go. First times first. You don't have to write all these down. Just make sure you know it. Last times last. It's just like the one before, just different letters, right? This one is not a difference of squares. This is not a full. We have to oi. So we're going to FOIL. Okay? First times first. This times this. 2 times 3. I'm going to change colors. Outside. 1 times square root of 3. Plus square root of 3. 1 times square root of 3, square root of 3. Inside, 1 times 2 square root of 3. Just 2 square root of 3, right? That was our outside and inside. Our last times our last. 1 times 1. Positive 1 times positive 1. 1. Okay. Our fulls are going to combine, and our ois are going to combine. Nobody talks like me. You're never going to hear another teacher say that. Sorry, this was my own language, not math language. Okay, this is 6. These two combine to what? 2 and 1 is 3 square root of 3's. Right? Right? And then we have the plus 1. So we have 6 and 1 is 7. Plus 3 square root of 3. I'm pretty sure, let me look really quick. I'm pretty sure that's the order they like it in, yes. What you should do is put the number first, because once you put the square root there, and you put plus 7 over here or something after it, sometimes it's hard when you're writing to see if that goes under the square root or not. So you're better off putting the number in front where you know it's not, definitely not in that square root. You could put it in either order. When you input it in my math lab, but this is the proper. Kind of like we put things in descending order. We normally put this before the square root number, okay? That's not a difference of squares, so we have to do the full FOIL. Square root of A times square root of A is A. Okay, what's outside, inside? Okay, the outside, square root of 3 times square root of A. Okay, remember when we did the cube roots, we put our cube root, we put the root there, and then we multiplied what's under there. So that's 3A is all under there. The inside, put the square root, multiply what's under them, you have a 2A. And the last times the last, positive times positive, 2 times 3 is 6. This is not going to be 5A. These are not like terms. I don't remember what number that is. There it is. Show you. See, it's going to be all spread out. It cannot be combined. All four terms stay there. These two cannot be combined. They are not like terms, so don't try to add those two. They have to be the exact same square root thing. The only thing you can add when you're adding is the coefficient, but they have to be exactly the same under the square root to be combining anything. Okay, so that's as far as you can go. It looked like I was spreading it out. We were going to be adding like terms and all that stuff. No, no adding like terms there. Okay, what about when it says squared up here? That means we have to write it twice and FOIL it. So we're going to have 2 plus square root of 3 times 2 plus square root of 3. Okay, so we're going to FOIL it. 2 times 2, 4. Wake up. Outside.
Plus 2.
2 square root of 3. Inside. Another 2 square root of 3.
Plus 2.
Last times last. Square root of 3, square root of 3 is 3. Like terms, 4 plus 3, 7. Like terms, they don't cancel, but they're both square root of 3 terms, so add their coefficients. 2 plus 2 is 4, the positive 4. Remember, you want the number in front and the square root following. And one more, then we're going to take a break, wake everybody up. Okay, so we've got, this is the same as square root of 5 plus 1, square root of 5 plus 1. First times first, square root of 5, square root of 5 is what? 5. High five. Outside, positive, 1 times square root of 5. Another positive, 1 square root of 5. For the inside, last times last, 1 times 1 is 1. We're doing the numbers first, right? 1 and 5 is 6. How many square root of 5s? 1 and 1 is 2. Any questions? Other than can we take a break? No other questions? Okay.